Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Here is a problem. CD are 2 points on the semicircle with diameter AB. AC intersects BD on E. AD intersects BC on F. Prove that the tangent lines from CD to the semicircle and EF are concurrent. So this problem is asking us to prove that the tangent line that passing through C and the tangent line passing through D and EF are concurrent. And we can recognize this figure is exactly the same figure that we mentioned in previous video, that this is a very classic figure, right? And we already know that because AB is diameter, so the angle ACB is 90 degrees, angle ADB is 90 degrees. That means BC is perpendicular with AE and AD is perpendicular with BE, which means F is the orthocenter of triangle EAB, right? So the EF is another altitude on the edge AB. So the question is that how can we find or how can we prove that the tangent line passing through C and the tangent line passing through D and EF are concurrent, right? So we can have different expression of this request, and different expression method can give us or can lead us on the different way to prove, right? So let's consider the first case, that we can express the problem to be that we find the intersection point of tangent lines and prove that this point is on EF, right? So we can first find the intersection point of the tangent line that passing through C and D, and then we prove that intersection point is on EF. And based on that, we can imagine, we can just assume that we got the tangent line intersection point as T, and then we want to prove that TF is perpendicular with AB, right? And with TF perpendicular with AB, we already know that EF is perpendicular with AB, so T must be on EF, right? That's the first way of prove this problem. And the second way is that we can find the intersection point of one tangent line and EF, right? We find the intersection point of one, for example, the tangent line passing through C and EF first. We call it T1, and find another intersection point of another tangent line with EF, right? So we can find, call it T2. Basically, we find the first intersection point of the tangent line passing through C with EF, right? We call that intersection point to be T1, and then we find another intersection point that's a tangent line passing through D and EF, and we call this intersection point as T2. And we just need to prove that T1 and T2 are the same point. Right. So that's a expression of the problem to be another way. And you can compare which way would be easier to solve this problem. I believe this way, right? Because we already know that C and D, it's like a pair in the whole figure, right? For example, A and B is a pair. C and D is a pair, right? So once we can find the relation between point C and the intersection point of the T1, the relation between C and T1, we can easily find the relation between D and T2, right? That's easier way. So we can, it's just like we reduce the work that we need to do, right? Now let's look at how can we get there. So let me just redraw the figure. The reason that I want to redraw the figure is to remove this tangent line, right? To remove some distraction. So we have AB here, CD here, this is E, right? And we connect AD, we connect BC, and we know that EF would be the altitude on AB, so we call this point as O, this as F, right? So we know that F is the orthocenter of triangle EAB. Right, now we think about, we draw the tangent line. As I said, that when we draw a tangent line, the first thing we need to think about is to connect the tangent point to the circle, or to the center of the circle, right? So we get the 90 degree, the perpendicular relation here. And let's call this point as T1. So what is the relation between T1 and C? Or what's the relation of the T1 to EF? Let's look at this angle, call this as G. So the angle GFB, right? The angle GFB, this is 90 degree, right? The angle GFB plus angle FBG equals to 90 degree. Right, this one plus this one, that's 90 degree. And we know that angle CAB plus angle FBG equals to 90 degree, right? We know this angle equals to this angle. So angle GFB equals to angle CAB. We've learned this before. This angle equals to this one, right? And we already know that this angle equals to this one. So it equals to angle T1FC, right? So let's look at this angle. Okay, this one, the angle T1CF. T1CF equals to angle T1CB, right? T1CF, that's the angle T1CB. And it equals to the circular angle reference to the arc CB, which is angle CAB, right? So that means we have angle T1CF equals to angle T1FC. This one equals to this one. And we know that angle BCE is 90 degree, right? Because BC is perpendicular with AE. So angle BCE is 90 degree. That means angle CFE plus angle CEF is 90 degree. And angle T1CF plus angle T1CE is 90 degree. right? So these two, the sum of these two is 90 degrees. The sum of these two is 90 degrees. And we already know these two are equal. That means these two are equal. So we got angle T1 CE equals to angle T1 EC, right? Which means, see, from here, T1CF, angle T1CF equals to angle T1FC. That tells us T1C equals to T1F. And from here, we know that T1C equals to T1E. So we know that T1 is midpoint of EF, right? And if you look at all the derivation here, it can be easily applied on the point D. So we know that for the point D, that T2 is also the midpoint of EF, which means T1 and T2 are the same point, right? So we know that the tangent line passing through C and the tangent line passing through D and EF are concurrent. So for this problem, that we provide two ways to think of it, and we find that another way, we just need to transfer our target, right, to be an easy way to express it, and different expression can lead to different way to prove. And with the second way of the expression, we can make the proof very easily, right? Okay, again, this is a classic figure. We will see it many times. And I hope you like this video. See you in next one. Thank you.